Hello, welcome back to my channel. It's been a while. New school year, so today I'll be going over isotopes, and as you can see here with the definition, isotopes are basically elements of the periodic table, so there's two or more of the same element with different masses. So we're going to have like 2 different hydrogens or 3 different nitrogens depending on the masses that they have. So essentially these elements, they can have the same number of protons but different number of neutrons, because again protons, they're the subatomic particle that identify the elements, so no matter what, protons always stay the same. So proton 1 is hydrogen, proton 2 is helium, so on and so forth. It literally gives you what element that is. But neutrons basically tell you what the isotope is, because neutrons affect the mass. So neutrons are in the nucleus as well as the protons. And neutrons can vary, so that basically differentiates the different isotopes of elements. Alright, so think of it as different versions of elements. And what do I mean by versions? So versions meaning it's different, there's a different aspect of something but the same identity, if that's a good way to describe it. So think of it as this way of an element. So let's say one day you're wearing a t-shirt, and the next day you're wearing a jacket because it's cold, and the next day you're wearing, I don't know, a hat because it's sunny outside. So you're wearing different clothes, so different versions of yourself every day, but you're still the same person on the inside. So the same thing kind of applies here with isotopes. Alright, so there are 2 types of identifying isotopes. So there's the hyphen notation. So basically, how do we know if it's an isotope? And I should probably use a different pen here. Let me try a way darker color. That's better. The hyphen notation, so essentially you just have, I'm going to use nitrogen as an example. -14. So what the hyphen notation is, obviously there's a hyphen, that's why it's called hyphen notation. What you'll have is the element's name, and then you will have your mass number. And remember how you find your mass number. That is always, again, the mass number gets to do with what's inside the nucleus, and the nucleus always has the protons and the neutrons. So mass number would equal protons plus neutrons. And then how do you find protons again? From the periodic table, and I'm going to write P table here. Alright, so just by looking at this example here, nitrogen, we can find it in the periodic table here. The atomic number is the top number here, 7. So proton number for nitrogen is 7, and then we can find the neutrons by subtracting. 14 minus 7 is 7. Alright, and we're going to do a bunch of more examples using this notation. But first I do also want to describe the nuclear notation. It looks different, but you can basically get the same information out of it. Alright, so I'm going to use nitrogen again. But this time, nuclear notation, you have to use the symbol. Alright, and the top number, let's do 14, and the bottom number is 7. So notice how very different the notations are, but you can still get the same thing out of it. So the N is obviously your symbol, and for the nuclear notation, you have to have the symbol. You can't write the full name here. So element symbol, And then you have these two numbers, so I guess that's the most confusing out of it, which one is which. So the top number is always, always, always your mass number. And what I like to think of it as the bigger number always on top. And then the bottom number is always your atomic number or your proton number. Because again, proton, atomic number go hand in hand all the time. Alright, so you gotta know the difference between the different notations, but the nice thing is, I personally like nuclear notation better, is because you have two numbers to deal with, and you can basically get everything that you need from the notation itself. So for example, if I were to ask you how many protons, how many electrons, and how many neutrons there are, you can pretty much get everything from here without even looking at the periodic table. Whereas this one, hyphen notation, you have to look at the periodic table if you don't have anything memorized. So we'll get the same answers for both, but so I'm going to show you the direction of how to find your information. So we already established this. So proton for nitrogen is 7. And again, that's the atomic number. Electron, so we're only dealing with neutral elements here. We're not dealing with ions yet, charged elements. Just neutral, which means protons and electrons are always the same. So if proton is 7, electron is also 7. And then neutron, this is what I'm saying, you gotta look at your periodic table. So neutron is when you have to do your mass number 14, you get it from here, minus your proton, you get 7. So this is pretty lucky, all of it's 7, but that's not always the case. And I'll give you some more examples on that. Now this one, this is what I mean by don't even look at the periodic table. So proton, as you can see here, that is my bottom number, 7. Electron, again, we're dealing with neutral elements, so proton and electron are the same, also 7. Neutron, I can just do top minus bottom number, boom, 7. So that's what I'm saying. It already gives you my atomic number here, so I don't have to look at the periodic table. Alright, so this is pretty much it with calculating isotopes. So I'm going to give you another example. Use a different color. I'm going to make up an isotope, but numbers are the same. So let's say I give you phosphorus, excuse me, dash 32. And I'm going to ask you the proton. I'm going to abbreviate now, P plus for proton, E minus for electron, and 0 for neutron. Alright, so proton. We are going to find the atomic number. So that is right here, phosphorus, and that's number 15. That's 15 protons. And now we have electrons, which is the same thing, in a neutral phosphorus. And then neutron, again, this is when we use this number here, 32 minus 15. (17) neutrons. Alright, so now I'm going to give you a different notation, so the nuclear notation with the different elements. Let's say I give you chlorine, so Cl. By the way, this is Cl, not Ci. You'll see chlorine a lot, and it may look like Ci, but no, it's Cl. There's no such thing as Ci in the periodic table. So chlorine, Cl, and I'm going to give you, let's say 40 and 17. Alright, so I'm going to ask you to do your protons, neutrons, electrons. And nice thing is you don't even have to look at your periodic table. So Proton, that is my bottom number. Electrons, same thing. Neutrons, top number minus bottom number. But if you still want to check your periodic table for double, triple checking, you are more than welcome to do that. So 40 minus 17, that would be 23. 23 neutrons. Okie dokie. So I'm going to give you one more example of each type, and then you will pause the video. And once you're done with the examples, you can play and then check that you get the right answers. So the hyphen notation, I'm going to give you silicon-30. And then the nuclear notation, I'm going to give you fluorine. All right. And you're going to find the proton, electron, neutron. All right, pause the video. Try this by yourself and then play to check. Alright, these are my answers. I hope you've got them all right. Again, with the neutrons, I just did 30 minus 14, which is my atomic number. And then with fluorine, I just did 20 minus 9, 11. Okie dokie, that's pretty much it for isotopes. I hope this makes sense, and have a great day.